and Dr. Ashish Suturi, who is the organizing secretary of this seminar, both will chair the session. Thank you, sir. Have a seat. Now, mic is hand over to you.
Thank you, sir. Now, once we welcome you all. Now it's my, a kind of blessing of former head of the HFL University, and it's my good luck that I'm sharing the chair with him. Thank you, sir, for giving me this opportunity. Yes. So, in the beginning, I would like to invite talk is very far from here. That is from Russia. Due to some unavoidable circumstances, because we had very clear in the first hand when we announced uh, this conference, we are conducting it in a hybrid mode. But after that, we have just concluded that we are not having a hybrid.
Mic.
participating?
Hello.
Camera.
So, due to some unavoidable circumstances, Professor Michael Japansky from Russia joining us virtually. So, I would like to invite him for his very wonderful talk on determination of the average annual values of the equilibrium concentration of boron isotopes in the modern residential buildings. So, without any further ado, I would like to invite Professor Michael. Are you able to hear me?
Hello, colleagues. Can you hear me?
Yeah, perfectly.
Okay, because there is not good sound from the auditorium, it's very difficult to listen. I am ready to present my reports. Are you ready?
You can just share.
Okay, I am beginning. 1 minute, please. Present, share screen. Can you see the presentation? Colleagues, can you see the presentation?
Yes, Professor.
Okay.
Yeah, just start.
Okay. You see, the topic of this report is the estimation of Toron average annual equilibrium equivalent concentration. The decay chain of the Toron gas is presented on the screen. It's well known, so I will not stop on this chain. The main problem is the inhalation of decay products like lead 212 and bismuth 212. The investigation which was carried out both in India and Cameroon in other countries demonstrated that there is the significant concentration of Toron to the total effective dose rate from 30 sometimes to up to 90%. So in average, the Toron products decay contribution to effective dose is comparable sometimes from the rodent decay products. Some measurements were conducted in Russia by our group, but it was more than 20 years ago. The average equivalent equilibrium concentration measured was in range from 1.1 to 1.7 becquerel per cubic meter, but in general, such level should be less because 25 years ago we have got not very sensitive equipment, but it was the only measurements conducted in Russia. According to Russia norms, we need to estimate the total equivalent equilibrium concentration of radon decay products, including radon and toron with coefficient 4.6 due to different dose coefficients. But there is a problem in the measurements of equilibrium equivalent concentration of toron, not instant, but averaged by time. In our other norms, there is the phrase, the measured of average value of toron EEC from the results of several measurements in short-tense mode, or sometimes by the single measurement. But during the even one day, the concentration of toron decay products can change very significant. It's impossible, like radon, to estimate by measurement of toron gas concentration and multiply by equilibrium factor. For radon, this equilibrium factor more or less constant. In Russia, 0.5, in Europe, 0.4. It depends on climatic condition. But for toron, it's range approximately one order of value. So it's impossible to use this value. So we need to make the direct measurements of average toron products, decay products concentration. Yes, there is some very original techniques based on the passive deposition of decay products, radioactive aerosols on the surface of detector, and the use of some absorbed layers. This detectors was made by Takanami and his company, his team. Some approximately the same time of detectors were developed in India, but also there is one very serious problem. We need, in reality, two serious problems. First of all, we need to consider the aerosol concentration in the point of measurements, because the deposition rate will depend on aerosol concentration. And second most important thing, if we need to use such measurements not for scientific purposes but for official purposes, we need to have got very good official meteorology assessment, meteorology support. I don't know practically any country in which such kind of detectors can be meteorologically attested. In any case, we will need to know the concentrations of aerosols, particles in the point of measurements. So we decided to use another approach. We estimated that the radon and lead 212 have got more or less big half-time time of decay. So their concentration, the ratio on their concentration will depend on the air exchange rate not very seriously. In real range of air exchange rate, the change will be not so high. So the approach algorithm such one, conducting the simultaneous measurements of lead and radon during 3-5 days, not more, and estimation the average concentration of lead and radon during the measurements. Calculation the lead radon ratio based on our results. Measuring of average radon concentration in dwellings by solid state detectors, maybe radon monitors during the long period, half year, maybe 1 year, to estimate the average annual radon concentration. And calculation of average concentration of lead using the average annual concentration lead to radon. And calculation the annual Thoron equilibrium concentration using the approximate ratio bismuth and lead. 0.5, it's a change not very high, so it's possible to use such approximation. Our equipment is the pump, 6 liters per minute, sampling time 24 hours, repeating samplings during from 3 to 20 days in experiments, in reality from 3 to 5 days. Also measuring of radon concentration by radon monitor. In these conditions, the minimum detectable concentration of lead is 0.01 becquerel per cubic meter for 24 hours of sampling. It's the scheme of measurements of radon and lead in simultaneous series. You see the measurements, it's radon scout, it's AlphaGuard, it's the sampling of results, and you can see that under the change of ventilation rate, it was specially organized experiment. The concentration of radon red and lead blue, of course, it's different scales, very similar. For long-term measurements, we usually use the nuclear track detectors like RADNET-IV. And we calculate the long-term concentration of lead by the multiplication of ratio short measurements lead to radon and multiplicate it for long terms of radon. Quite simple. Of course, we made the assessment of such approach. We made the long series from 10 to 24 days, parallel series of measurements of lead and radon. All series was estimated like a little proxy for the long-term measurements. And we estimated what error, what uncertainty will be if we will make the short 1, 2, 3 days measurements of our short series. The results are presented here. We made the 7 long, more or less long series, and short series duration. It's the coefficient of variation lead to radon ratio. You can see that from 3 at least to 5, the best parallel series, we obtain more or less good coefficient of variation of estimate ratio of short-term to long-term series. We estimated the uncertainty budget. We estimated the uncertainty of detectors, count rate, calibration coefficients, and so on. The influence on ventilation, change of ventilation rate during the sampling, quite a long list of uncertainties. As a result, we obtained general budget of uncertainties. For 5 days measurements, the most uncertainties is the effects of uncertainty of representativity of simultaneous series and uncertainty, Plumbum-Redon ratio dependence on air exchange rate. But in general, total uncertainty was more or less good. Of course, we made the measurements, such kind of measurements in Yekaterinburg city, in different objects. Usually it was the rooms in multi-story buildings. The measurement was made by non-destructive techniques. It will be presented in our next report. And you can see the results. In general, we can observe more or less good correlation between the estimated average annual radon equivalent equilibrium concentration and the average Toron-specific activity in all building materials in flats or offices. Difference, of course, exists, and in general, this difference can be explained by influence of room ventilation modes and the nature of decoration of the walls, floor, and ceilings, because for Toron it's very essential the diffusion barriers between the source, like concrete or bricks, and the atmosphere of room. So even the small layer of wallpaper painting can considerably change the diffusion of Toron from the wall to room. And the results. Our preliminary measurements in Yekaterinburg city demonstrated that Toron equivalent equilibrium concentration for modern multi-flat multi-stories buildings approximately 0.72 becquerels per cubic meter, and it corresponds to effective dose 0.35 millisievert per year. We demonstrated that our techniques can be optimal, more or less, during the measurement time from 3 to 5 days. So we need to put our pump and filter in flat, made 3-5 days measurements. Simultaneously, we use the measurements of radon concentration, and later we consider this short series, compare this short series with the long-term series made, for example, by nuclear track detectors. The total uncertainty of assessment depends from 0.44, it's big value, but to 0.32 for 5 days measurements respectively. So our results allow us to make the assessment of Toron exposure for more or less typical kinds of building based on the average value of Toron concentration in building materials, because we understand that it's more easy to measure the concentration of thorium in building materials than to measure the annual average concentration in air. I just repeat the total relative uncertainty of EEC measurements, approximately 0.35. And also very important, these techniques can be supported by the typical standard metrological support, at least in Russian state standard system, because it's possible to measure the sensitivity of nuclear track detectors, radon monitors, and alpha radiometers used for the measurements of thoron concentration. All of these measurements can be tested by Russian state standards and implemented in some techniques which can be used for assessment. Thank you.
Yes, please. Professor Michael, are you able to take one or two questions from the audience? Hello? Am I audible?
Hello, sir. Professor Michael. Audible? Hello. Hello.
Hello, Michael. Could you please unmute?
Yeah.
You are muted. Yeah,
Yeah,
now
yeah.
again, you are muted. Please unmute yourself. Michael, can you hear us? Hello. Can you hear us?
Dear colleagues, very bad sound. Sorry, I don't know how you can listen me, but I practically cannot hear you.
Now is it fine? Hello.
Very calm, sir.
Hello.
A lot of echo.
Michael, can you hear us? You are muted. Please unmute yourself. And can you hear us? Please respond. Hello.
Yeah, I can listen to you. Okay.
You can hear us now?
Yeah.
Okay. So there are some questions for you. Will you take one or two questions?
Yeah.
Come.
Professor Michael, you are giving a wonderful talk. One question related to the thoron. Thoron varies from building material from the wall and ground. What is the distance you are consider for estimation of EC of a Toran for estimating that value? What is the distance you are consider?
Sorry.
About the distance of the measurement from the wall. When you made the measurement inside the room, what is the distance of a detector from the wall?
Of course, the distance of detector. We try to put the detector in the middle of the room, but because we are measuring not the Toron gas, but we are measuring the decay products, so there is less influence of distance on the concentrations. Our measurements, which we conducted some years ago, demonstrated that the ratio of gas near the walls and gas in the center of the room can be 3 times in average. For the decay products, we used the literature data. It's very difficult to make the simultaneous measurements. But we tried to put the pump approximately in the middle of the room. Thank you.
Any other question? So thank you, Professor Michael. Now we are signing off. Yeah. Now we are inviting the second, that's under the oral presentation category. I would like to invite V.S. Izagin from Russia as well.
Oh, yes.
Hello, am I audible? V.S. Izagin, am I audible? Just put on your mic and hello, am I audible?
Good afternoon, dear colleagues.
Yes,
Слава, ты готов? Dear colleagues, Vyacheslav Izgagin, he is my PhD student, and we discussed, and it was supposed that I will present this report also, if it's possible.
time for 10 minutes. Now you're most welcome. The next oral presentation on natural negative tags in building materials of residential buildings as a source of external population exposure. Now, mic is over to you, Professor Michael.
Okay, 1 minute, please. Settings. One minute. There is some problems with presentation. Okay, can you see the screen? Dear colleagues, I would like to present you our next reports. It's the same team like the previous report. It's a measure of natural radionuclides in building materials in buildings. The problems is well known because from the 1960s the calculation were conducted and estimation were conducted. In Russian norms, there is such requirement for limitation of effective equivalent effective specific activity of natural radionuclides, depending on concentration of radium, thorium, and potassium. It should be less than 370 becquerels per kilogram. In European Union, there is close but a little different requirements. There is the limitation of activity concentration index. But in general, this approach more or less close. But we analyzed and we can see that there is no direct measurements of external population exposure considering the actual content of natural radionuclides in building materials. Not standard house or some model house, but in real houses. It's very difficult to conduct such measurement because it's practically impossible to obtain the sample of building materials from existing buildings. No one will give you 1.5 kilograms of building materials from different walls. So the research task was to conduct the measurements in large Russian cities in different zones using the gamma spectrometry and estimate the effective dose from natural radionuclides using the real, both the real and model room spectra, and using the conversion coefficient from air kerma to effective dose based on the contemporary ICRP publication data. We used the standard field gamma spectrometer manufactured in Belarus. Usually it's used for the really field measurements. But we made the calibration of sensitivity, efficiency of the photopeak to flux density of unscattered gamma quanta. And next approach, we calculated the unscattered gamma quanta flux in the real room, normalized it to unit specific activity. So we measured the dimensions of the rooms, estimated the thickness of the wall, the density of the wall, and we calculated the expected value of the gamma quanta flux in the middle of the room to make the measurements. We made the real measurements of gamma spectrum with the fixing location of the detector, and we calculated the average specific activity by comparing of the measured count rate in the photopeak with the calculated flux density of unscattered gamma quanta in the room. So we made for the room two things. First, the real measurements of unscattered gamma quanta flux and the calculated, expected, normalized per the unit of activity. We used for radium two lines, usually more high energy line. For thorium, most high energy line. For potassium, the only line. This sensitivity was calibrated by standard sources instead of potassium-40 sources, because it's impossible to create such high activity sources. We used the Europium 152 line, 1408 kilo electron volts, and made some corrections. Of course, during the calibration, we subtracted the background spectra. The typical spectra are presented on this picture. You can see the radium lines, but also the blue line is the thorium near 600 kilo electron volts. So there is the interaction. For potassium, we obtain the single line. For radium, 1000.76 mega electron volts is practically the single line, and for thorium also the single line. So it's the radium, but we used not this point of spectra, but this part of the spectrum for radium. In a special program, Microshield, we calculated the gamma flux density for different geometry. It's the wall, it's the floor or ceiling, different points. And the average activity was calculated as the ratio measurement intensity to calculated activity multiplied by 100 becquerel per cubic meter, because the calculated count rate was made for such activity. Real measurements was conducted in 8 regions of Russia: Moscow, St. Petersburg, Yekaterinburg, Tyumen, Chelyabinsk, Tyumen, Salihard, Krasnodar. So from south to north, from east of European part to west, quite a big square was covered. The typical picture from the measurements point, it's the room, detector in the center of the room, all dimensions of the room, the dimension distance from the detector to the wall was measured by a special detector. Laser. The expected flow rate was calculated by Microshield. All building structures were divided to some elementary volumes, and each elementary volumes was considered like the point source, considering the absorption, dispersion, and so on. Also, we calculated for different energy lines. For radium, it was 24 energy groups. For thorium, 20 energy groups. No, for potassium, it's the only line. And we also used the conversion coefficients based on ICRP publication 116 to conversion from Kerma to effective dose. This is the data on the average concentration of different radionuclides in 8 big cities of Russia. You can see that there is significant difference. For example, for potassium, it can be changed during practically 3 times and more. For thorium also. For radium, there is also big differences, and also for effective specific activity. We compared our data with archives data of St. Petersburg Institute of Radiation Hygiene. In some cases, we have got the good correspondence, in some cases less correspondence, but the reason was due to the fact that we measured in general in modern multi-story buildings. The total archives concerning the data on materials, building materials during a long time. It's the effective dose rate. Also, can you see that most radioactive city, St. Petersburg, most later is Yekaterinburg, Chelyabinsk. In other cities, the total dose rate due to natural radionuclides in building materials is not general. It's dose rate from radionuclides from building materials divided by radionuclides. And the relative contribution of different radionuclides also presented here. You can see that in practically any cases, the most important radionuclide is potassium-40, then the thorium and radium is less. But this ratio is important in general only for the cities with maximum dose rate. It's St. Petersburg, Yekaterinburg, and Chelyabinsk. For other cities where the total dose rate from building materials not very high, this ratio is not very important and not very significant. We try to calculate the average, estimate, not calculate, estimate the average dose rate from building materials, maybe not for all Russia, but for European part of Russia. It will be more correct. We estimated the average area of the living stock, estimated the weighting coefficients between the different cities, and estimated that the average annual dose rate due to multi-story buildings can be estimated as 0.22 millisievert per year. Indoor stays, 7,000 house per year. You can remember that the dose rate due to Toron in previous our report was approximately 0.32. So the external gamma rate not very high, incomparable with other situations. Also, this is the average specific activity averaged on all European part of country, and effective dose rate also averaged by radionuclides for the European part of Russian Federation. This is the conclusion. It's in general the repetition of the, so it's the average radium, thorium, potassium-40 concentration, effective activity, average dose rate with the range, and the estimation of average annual effective dose. Thank you.
Thank you. Thank you, Professor Michael. Is there any question from the audience? Then you can take 1 minute. Okay, I think you have already given a lot of answered all queries in your first presentation. Thank you, Professor Michael, for joining us virtually, and definitely we would love to welcome you here in person in near future. Thank you, Professor Michael. Now we are signing off until we meet again. Thank you.
Thank you.
Now, I would like to invite the other oral presentation from Amit Sharma. Amit Sharma. His presentation on mapping of outdoor gamma ray radiation and assessment of associated health risks due to its exposure in Alwar district of Rajasthan.
Hello. Good afternoon, everybody. Myself, Amit Sharma from Alwar, Rajasthan. Today, my presentation topic is mapping of outdoor gamma radiation and assessment of associated health risks due to its exposure in Alwar district of Rajasthan. Natural radiation is presently everywhere and exposure is unavoidable. Natural sources talks for 87% of total radiation dose received by living beings on Earth. Natural radionuclides like uranium-238, 235, 232, thorium series, and potassium 40 and radium-226, which emits gamma radiations that generally come from cosmos and terrestrial sources like food, building materials, and human body. Two types of natural radiations found cosmic rays and terrestrial. Terrestrials I explained that is, human body, food, air, water, building, etc. The in the cosmic radiation dose is 32 nanosievert per hour and terrestrial radiation dose 59 nanosievert per hour given by the United Nations Scientific Commission. My study area is Alwar district. Alwar district is northeastern part of Rajasthan state, which is located between 27 degrees 03 minute and 28 degree 14 minute on north latitude, while east of longitude is 76 degree to 77 degree 30 minute. Climate of my district is sandy arid, characterized by very hot summer and very cold winters, very fairly good for any fall. In May and June and summer season, the temperature go up to 47 degrees. It's my study area and locations where I collected the samples and measure the gamma radiations. This methodology, I use Polymaster PM1405 instrument for measuring the radiation. First of all, I divided my district in 6 by 6 kilometers square small grids and measurement of outdoor gamma radiation in summer and winter season. Summer that means pre-monsoon and winter means pre-post monsoon. Then 2 seasons I collected Polymaster, the instruments I used and 193 locations. At 193 locations, I take measurements. First of all, the meter placed 1 meter above from ground and 5 measurements were done to take mean value of gamma dose rate. This instrument has the measurement limit 0.05 to 3.0 mega electron volt and detection range for the dose rate 0.01 microsievert per hour to 100 millisievert per hour. This is the formulas to calculate AED and ELCR. AED means the annual effective dose equivalent and ELCR annual lifetime cancer risk. Outdoor gamma radiation rate के लिए ये histogram shows us that 101 to 150 is the measurement range. Number of samples, huge number of samples are measured in between this range 101 to 150. Same is in post monsoon. Outdoor gamma radiation pre-monsoon, post-monsoon season, there's the variation graph where I found that in pre-monsoon, average, minimum and medium, maximum values are found to be in comparison of post-monsoon. I take 193 samples, but all samples have greater values than Indian average and world average. These are the results. The interpolation record of outdoor gamma radiation of Alwar district is shown in figure 6. Area and ELCR I calculated for my study area. Locations AD and ELCR and even AD. ELCR and okay, ELCR and AD is found to be greater than Indian standard and world standard. ELCR value, there is world mean value, then this is that was 0.29 into 10 raised to power minus 3, and AED value is 0.07 millisievert per hour. But by samples, my locations have more than values compared to these values. AED in pre-monsoon and post-monsoon, winter and summer times. Here is also the pre-monsoon values are greater than post-monsoon, and by comparison to by world average, it found greater than world average. These are annual effective dose in Alwar district. That was one post-monsoon, and this one is pre-monsoon. Finally, for the conclusion, about the gamma radiation rate at all location higher than Indian and world average value, but within the typical limit of 20 to 200 nanosievert per hour. Similar trend of AED and ELCR was observed, like GDR. Baseline data GDR generated, but to correlate its health perspective, survey need to be done. Prevailing alluvium finally, I want to say prevailing aluminum is possible source of its higher side of outdoor cover radiation. These are references. Thank you.
Now we can take one or two questions from the audience.
Yes, sir.
Those 3 months is higher than the 4 months. What is the reason?
Sir, the reason I think it could be summer and dust particles. Due to summer, it can be dust particles. May I use Hindi? सॉरी डस्ट पार्टिकल्स के कारण क्या है, समर के टाइम डस्ट पार्टिकल्स ज्यादा होते हैं, तो हो सकता है उसकी वजह से एक्सपोजर ज्यादा हो.
What is the relation? Dust particles to
डस्ट पार्टिकल्स एक्सपोज करते हैं सर. डस्ट पार्टिकल so many regions but one of the region dust particles.
Dust particle contains radionuclides?
Maybe or may not be, depend on environment.
How you say that the dust particle is the reason?
One of out of them the region.
No.
Okay, sir.
Okay.
Thank you.
Thank you. Now, being a part of organization team, I'm very happy that we'll have a last presentation, but not the least. Now, I would like to invite Kavita Chahal for her presentation, radioactivity in food samples of Punjab and Haryana states.
Good afternoon, everyone. My name is Kavita Chahal. I am doing PhD under the supervision of Professor Sunil Kumar in Department of Physics and Astrophysics from Central University of Haryana. And my presentation topic is radioactivity in food samples of Haryana and Punjab, India. And I have done this work in collaboration with Department of Nutrition Biology from Central University of Haryana. This is the literature survey. As according to International Atomic Energy Agency, if natural radioactive nuclides like uranium, thorium, potassium can contaminate our soil, water, and food, then there should be a hazardous health effect if they cross the safe limits. The terrestrial radiations, which originates due to decay of any radioactive materials like rocks, vegetables, etc., and spread throughout the surrounding environment. And the natural radioactive nuclides can have potential to migrate from soil to plant and contaminate our food samples. And the mining and the processing of phosphate fertilizers contaminate the surrounding soil, and the application of the fertilizer over time to increase the concentration of radionuclides in agricultural soil and transfer these radionuclides to the food chain. And recently report came in 2020 that in Haryana, around 16,000 people were dead due to cancer. So it's very important to study the radioactivity in food samples. So that's why I started working on this project. Initially, we selected the brain samples from various places of Punjab and Haryana. For this, we were collected the sample, and immediately the brain samples goes to laboratory for further analysis. And the radiation count was carried out in Department of Physics and Astrophysics with the help of GM counters. We calculate the radiation counts. And further, bread samples were prepared in Department of Nutrition Biology at the Central University of Haryana, because bread is a universal meal. And these are the steps as we followed for the processing of food samples. And initially raw ingredients like sugar, flour, yeast, salt, oil, etc. were collected, and then bread oven was used for the processing of food samples, and immediately packing of the bread samples, otherwise contamination will take place. And at last, nutrition analysis and radioactive nuclei evaluation were carried out. These are the machines which we used for the processing of food samples. And legal ruler counter was used for the estimation of radiation count in grain and food samples. Here, as you can see in bar chart first, that the radiation count in Bathinda region is maximum for grain samples, and similar results was found for food samples. Here, for nutrition purpose, we also calculated the shelf life and moisture content, and these are the physiochemical parameters of food samples. Here, in horizontal line, you can see the shelf life, and in vertical line, you can see the moisture content in bread samples. And the shelf life of the bread samples for gene heuristic is maximum, and we found bread shelf life is minimum for Sona and Sesa region. In conclusion, this study depicts the radiation count in grain and prepared food samples in 6 different regions of Punjab and Haryana. The radiation count for both grain and food samples was found maximum in Bathinda region. This study helps to understand high radioactive regions which have not only passed this to the brain but also to the consumable food in those areas, leading to health hazards. And the measurement of radioactivity of consumable is important with respect to improvement of quality of life and mitigating the occurrence of diseases. These are the references. And at last, I would like to acknowledge my supervisor and first supervisor for their constant support and guidance, and my sincere gratitude to Dr. Ranjit, Dr. Amarjit, Dr. Balvinder from Guru Jamnesar University of Science and Technology, sir, for their help during my experimental work. And at last but not the least, I would like to RADNET for organizing this wonderful conference and for giving me this opportunity to represent my work. Thank you.
We can take one by one or 2 questions from the audience.
You are measuring only gamma.
Yes, sir.
You have to think that to measure the radionuclides in the food samples
Yes, sir.
in future.
Yes, sir. In future, sir.
That is better.
Yes, sir.
Can you go back to the data you have shown, the bread?
Yes, sir.
Can you go back to the slide? Yeah. So we have taken a simple GM counter to measure the gamma rays.
Yes, sir. Because it's a fundamental, sir.
So, but for how long you have taken the counts?
No, after processing.
And for how long you have taken the counts with the detector?
Sir, generally, we just idea that in which region radiation count was maximum.
No. Because you have been using GM counter, how much time duration you have taken for a sample?
Acquisition time.
Sir, 7 to 8 days. 8 days.
Continuous.
Because sir, you
No, you have switched on the GM counter for 8 days continuously.
Not possible.
no, sir. 15 minutes, sir. Yes.
So in a single shot, you have gone for 15 minutes, right?
Yes.
Okay. And what is the order of background during that time? Without the source, you have taken the background counts of.
Yes, sir. Around 33. Sir, in our lab, it's 33.
And what is the maximum counts you have seen with the sample?
Yes, sir.
What is the maximum counts you have observed with the sample?
Maximum counts are around.
Thousands or hundreds?
Is it in hundreds or thousands?
No, sir. No, sir.
How much?
No, sir. It's.
It should be more than 33.
That would have been
Sir,
sure. Yes,
no, sir. It should be less than 33. Background counts. Sorry, sir. Should be maximum, sir. Should be greater than 33, sir. तो सर जो हमने रेडिएशन बैकग्राउंड काउंट से माइनस किया तो वो सर अराउंड 10 11 ही आ रहा था, सर ज्यादा नहीं आ रहा था.
And what is the distance you have taken from the sample?
सर जस्ट वो टच नहीं होना चाहिए सर उसके ऊपर वाले इसके
Is there?
जो
अभी नीचे.
What could be the possible reason? In some area like zinc,
yes sir.
the effect is a bit different when you compare from others, right?
Yes sir.
What could be the reason?
Sir, because sir, my father is also a farmer, sir. The gene, sir, जो farming है sir, it's a organic farming. And in Bathinda, sir, there is as we know all know that it's a very contaminated area in the point of in soil point of view, sir. Sir, so it's
Good luck for you.
Thank you. Now almost we have completed the technical session. And thank you, Professor Shimon, for sharing the dice with me. Thank you.
सैपलिंग कर रही है ना नीचे हो जाएगी सब जगह सैपलिंग नीचे
before we begin with our I would humble request to our guest, Dr. D.K. Aswal, Professor B.S. Sainwal, Dr. Shailja Pant, Professor R.C. M.P. Nagpal, Professor Kuldeep Singh, Dr. Ashish Raturi to proceed towards the stage, and please have your seats. Please welcome them with a round of applause. It is good to have an end to the journey, but it is the journey that matters in the end. A warm and pleasant good evening to one and all present here. I, Dr. Aditi Chauhan, take this opportunity to extend a hearty welcome to each one of you to the valedictory function of the first International Conference on Radiation Awareness and Detection in Natural Environment, jointly organized by Dolphin PG Institute of Biomedical and Natural Sciences, Dehradun, and Government Degree College, Dehradun, in association with Department of Physics, HNB Garhwal University, and National Road Network Society, RADNET. It is indeed our pleasure to have amongst us the chief guest of the valedictory function, Dr. D.K. Aswal, Director, Health, Safety and Environment Group, BARC, Mumbai. Guest of honor, Professor B.C. Sainwal, former head, HNB Garhwal University. Dolphin Institute of Biomedical and Natural Sciences. Professor M.P. Nagpal, Principal, Government Degree College, Dehradun. Professor R.C. Ramula, Senior Professor, HNB Garhwal University, and President of RADNET. Dr. Shruti Sharma, Coordinator, IQAC. Professor Kuldeep Singh, Assistant Director, Higher Education, Uttarakhand, and the convener of the conference, and Dr. Ashish Raturi, Organizing Secretary, RADNET, to grace this occasion. Now I request Professor R.C. Ramula to welcome our chief guest, Dr. D.K. Aswal, with a sapling. Please, sir. Please give a big round of applause. It's my humble request to Dr. Shailja Pant to welcome Professor B.S. Sainwal by presenting him a sapling. Please give a big round of applause. Now I request Professor Kuldeep Singh to welcome Professor R.C. Ramula with a sapling. It's my humble request to Dr. Ashish Raturi to welcome Professor M.P. Nagpal with a sapling. It's my earnest request to Dr. Shruti Sharma to welcome Professor V.M. Chaubey, former scientist, Wadia Institute, Dehradun, by presenting him a sapling. Please give a round of applause. For the past 2 days, we have experienced the plethora of technical talks and paper presentations by the delegates and participants from our country and abroad. Now I would like to invite Professor Kuldeep Singh, convener of this international conference, to come up on stage and give us a brief overview of the highlights of the last 2 days. Please, sir.
Thank you, ma'am. Respected Dr. D.K. Aswal, sir, Director, HSNEG Group, BRC Mumbai, Chief Guest of the function. Professor B.R. Simal sir, my guru, my guide. Sir, I am honored to have you here with us on the dais. MP Nagwal sir, Principal Government Degree College, Dehradun sir, guest of honor function. Professor R.C. Ramula sir, President of the Society and Convener of the workshop, present over here. Sahaja Pankman, Principal, Dolphin PG Institute, Dehradun. My Organizing Secretary, Dr. Ashish Saturi, Dolphin PG Institute, Dehradun. All the delegates present over here, faculty members of Dolphin PG Institute, faculty members of Government Degree College, Dehradun Sahib, research scholars, media persons, last but not least, students of Dolphin PG Institute. I welcome you all in this validity function of the conference on behalf of the organizing committee, on behalf of the National Radio Network Society, RADNET India. The conference started on 2nd of March and was inaugurated by Professor Annapurna Natal Ma'am, Vice Chancellor HNB Global, Central University, Srinagar Global, followed by a invited talk delivered by Dr. D.K. Saul sir. Initially, when we start calling abstracts, we received 114 abstracts for the presentations. It was very hard task for us to select abstracts for oral and poster category. All abstracts were very good, but anyway, we, the organizing committee, selected 34 abstracts for oral presentations and remaining 80 abstracts for poster category. 23 speakers from country and abroad were invited for delivering invited talks. The technical program was divided into 10 technical sessions. Out of 23 invited talks, 22 invited speakers delivered their talks in last 3 days. Out of 34 oral presentations, 32 oral presentations were presented, and out of 80, 60 posters were presented during the last 3 days of the conference. Total registrations were 120 in this conference. All the key points and theme of the conference were covered and discussed during the technical sessions of the conference. There was also very good and healthy discussion during the technical sessions, and many times we saw the discussions continued during the tea sessions and duration of lunch also. These kind of things makes an event a grand success. We tried our best to provide you best local hospitality, and I hope you all enjoyed it. But in spite of taking care of all these, if anybody felt any kind of trouble, I apologize that on behalf of the organizing committee. The vote of thanks will be presented later on, but I can't stop myself from thanking a few persons. I thank Dr. D.K. Saul sir for spending his valuable time among us. I thank Professor B.R. Simal sir for accepting our invitation and gracing the occasion here. I thank Chairman of Dolphin PG Institute, Dehradun, and Principal Man, Dolphin PG Institute, for providing us all kind of support and facilities. I also thank Professor Ramula sir for his belief and trust which he has shown on me. I thank you so much, sir, for your guidance and support. I thank Dr. Ashish Saturi, Organizing Secretary of the conference. It was a great experience for me to work with you, sir. I also thank Dr. Sudhi Sarma, Dr. PG Institute, Dehradun. And my special thank from the bottom of my heart goes to Mr. Sudhir Bharti, sir, for his wholehearted efforts to make this event. Last but not least, the whole organizing committee, I thank the whole organizing committee, the whole team, all committee members, officers from higher education, teaching staff of Dolphin PG Institute, teaching staff of my college, non-teaching staff of Dolphin PG Institute, and students of Dolphin PG Institute, Dehradun. Thank you all for making this event a grand success. Jai Bharat, Jai Uttarakhand.
Thank you, sir. Ladies and gentlemen, we hope you found this conference informative and engaging. We would love to hear your thoughts on the conference and suggestions you may have for such future conferences. We invite any participants who would like to share their feedback to come forward and speak with us. Your comments are important to us and we value your input. Please, Amy.
Professor Sannappa from Karnataka University of Mysore. Dignitaries on the dais, President of the RADNET, Professor R.C. Ramala, and all the members, society members. So the 3-day international conference organized by this institution and RADNET, as my opinion, is very good and successfully organized. And any facilities and accommodation provided by this society and biomedical center, this college, organized and provide the accommodation is very good. I think I have attended many number of international conference. This conference, all for the international conference, there is no difficulties, I think, faced by the members. So this will be continued. And the Ramala is a very key role to organize. It is a very high skill to organize, how to organize the international conference. So on that, he is well planned and organized. No difficulty faced by the United Talkers as well as the students and research scholars, all of them, to provide all the facility also. In this connection, and another one thing we have observed in this conference, one of the important point is the conference is organized by the student, faculties, and all even industrialists also. Interaction is very important. So some time is given to the most of the discussions because the young students, young researchers are coming out. So how to research, what are the difficulties, what is the some uncertainties will be faced to carry out the research and everything discussion and suggestion is very important to give the some students. This will be taken into account for the future conference. So in the direction and another important one direction is suggestion, not direction. Suggestion is so in the past, in future days, most of the conferences are organized interdisciplinary. In this aspect, the irradiation polymer is the most widespread in future also. No? Today is also the research is going on the irradiation of the polymers. Most the interest is given to that field is also because it is a radiation purpose and radiation shielding material is also taken into consideration for the future purpose to important and introduce into the brochure also. This is the some few suggestions given to this organizer. So I am very much thankful to the committee and especially Professor R.C. Ramala to organize a beautiful and wonderful conference. There is no difficulties. All are enjoy. Very good, very pleasant atmosphere in this Uttarakhand, especially Dehradun. I am very much. I am also glad to the Karnataka. So very good. So thank you, Vandana.
Thank you, sir. Anyone else?
Good afternoon to everyone. Dignitary on the dais, Dr. Oswal, Dr. Samal, Dr. Professor Ramana, Dr. Nagwal, and other dignitaries on the dais, and my dear colleagues from the wide range of institutes throughout India, and my dear students. It has been a pleasure to be here on the dais this evening on this closing ceremony of the great international conference, of course. on radiation awareness and detection in the natural radiation, what we usually call as RADNET-IV. And as I'm aware, this is the fourth continuous conference in this direction, organized earlier by, of course, one of them by Professor Ramona, one at the ERC. And this was the first international conference in this direction, where I think most of the people have observed a wide range of participation from the international dignitaries, led by Dr. Sahu and his team from Japan. I think around 10 of them has been from the University of Micropolitan Tokyo and other universities in Japan. As well as this was the conference where we have the people from Hungarian, as well as from Taiwan and others international countries, of course. And of course, I have attended so many conferences so far, around maybe more than 30 or 40 international on the national level, but this is the only conference where I have seen around 120 abstracts outstanding. And that's one of the wonderful things, I think, the response to this conference has been given. And more wonderful was that of that 130 abstracts, as I can know, there was around 24 talks, if I'm true, around 24 invited talks, around 34 oral presentations, and more than 80, of course, posters. Out of that, around 60 would have been here. So more or less around 95% of the people who have given their inputs in terms of abstracts, they have been here in this conference, and that's the best thing. You can see how the organization has been too good. Regarding the technical session, this has been extensively divided on radar activity as well as on radiation damaging, on protection, and I'm thrilled to have an international session where a large number of the participation was from Dr. Sahu's team from Tokyo Micropolitan and other universities. And even there was a very nice talk and very informative talk on radiation biology, which is, I think, Dr. also indicated as well, which is the need of the future. So from the radiation environment, I think now we are in the position that we have to go for radiation biology in terms of not only awareness, those things on the back. Now you have to go for the future field like radiation biology, like radiation protection, and maybe developing the new detectors which can be used in future. There was one presentation I heard today where a wide range of detectors from sodium iodide, nowadays they have come up to barium chloride, I think, given by a professor from IIT Roorkee. So these are the direction I think we have to think of. And the most informative part of the conference was that this was divided into 10 technical sessions for the 3 days. And I think what I have personally seen, most of the people have been busy from 9:30 to 6 o'clock every day. So that was the thrill of the conference. And another part was there was one technical and dedicated session to uranium and its health impacts, and of course something very related to epidemiological study, which is need of the future, that how exactly radiation can cause some cancer issues or other, as of course in the first talk given by Dr. Oswald. And then, if I'm not missing, there was one complete session on earthquake prediction study. And I think India has been now taking, if I'm true, quite great initiative in this direction. And especially the Ministry of Earth Sciences is coming in this direction for installing a wide range of networks for a pre-cursory study where our previous colleague, Dr. Walia, working in one of the Taiwan's Earthquake Prediction Institute is working in. And that is even the need of the future at present. So we as a radiation scientist or radiation worker, I think we have to think of the future aspects as well, and which of course, I'm sure our president of the Radiation Awareness and Protection Natural Environment Society, Dr. Mola, will take into consideration in future as well. And I think we should also take guidance from Dr. Osborne, as he has indicated, to be jumping the future aspects of the radiation and its application for mankind, especially for the society in general. So Outside not taking much time, there's been many speaking more. I congratulate you to the organizers and of course your team as well, and who has taken a really good step and invited the participants. And one thrilling aspect which I'm just missing was one session on where I think in future there's going to be international collaboration between the people from India and people from Africa and people from South Asia, taking building a network for the utilization of radiation for future mankind. And that's one of the great aspects this conference has also taken into consideration. And I think if I'm not missing, this was on the line of a European collaboration. There have been a European collaboration in this direction of all the European countries. Similarly, this would I think would be a starting step in the direction where our organizers, our scientists from abroad, from different fields, as just indicated, they will come forward and I think they will certainly take into consideration few steps where our future generations which are working in this field will certainly take the knowledge and go ahead in this direction. So these ones, of course, I thanks the organizers for giving us an opportunity in interacting with the international scientists from a wide range of countries here and giving us an opportunity to enjoy the weather. Of course, we are not able to enjoy the city because for plenty of time we didn't get any time to still visit the city. So maybe in the evening we'll try to. And I'm thankful to the organizer as well for giving us a very nice hospitality in terms of a nice food and nice accommodations, and of course a nice thrilling activity of the yesterday's evening. So with these words, I close my words. Of course, there will be many more speakers who can give their feedback as well. So I'm thankful to the organizers and to the committee, and of course to everyone, my colleagues and everyone for coming here and filling and enjoying and activating your knowledge. Thank you.
Thank you, sir. Ladies and gentlemen, it's my great honor and pleasure to invite Professor M.P. Nagwal, Principal Government Degree College, Dehradun, to address the August gathering. Sir, please.
Thank you, ma'am. This is the great opportunity for me to invite this session. I am very pleasure and feel well. All the dignitaries and experts, highly experienced, during the 3 days discussing to each other's some questions raised and the answering some maybe conclusion is a very useful and fruitful for human being. The Government Degree College, Dehradun Shahar is very newly college established just 2 years ago, and my college and their staff is excellent, high talented, and doing something which is top level, which is extraordinary in the field. So I am very proud of it. Professor Tulip Ji, who is leading a physics department, is brilliantly these seminars, and all staffs are very collectively help them. I will best of luck for future and happy and wishing a very colorful occasion, festival, Holi of all you. Thank you.
Thank you, sir. We are honored to have with us Professor R.C. Ramola, President, RADNET Society, I would like to request him to kindly share his thoughts with us. Please, sir.
Thank you very much. The dignitaries on the dais, our mentor, I would say, most respectable Professor B.S. Maldi, and the chief guest of this particular session, Dr. Ashwal, who is also the alumni of our university and student of Professor B.S. Maldi, and principal of the Government Degree College, Professor M.P. Nagwal, and principal of this Dolphin PG Institute of Biomedical and Natural Sciences, Professor Pant, the convener of this conference, Professor Kuldeep Singh, the organizing secretary, and Dr. Ashish Tapuri. And I'm very, very happy to see my old colleague, my old friend, Dr. V.M. Chobe from Wadia Institute of Himalayan Geology. I was not aware of that he's in Dehradun, because he most of that time he lives in Australia. But when we got some information that he's in Dehradun, I thought him, and he very easily and very quickly accepted it and came over here. And of course, the vice president of RADNET, and I'll say my colleague, because as I told you in the opening session that my roots are in Guru Nanak Dev University, Professor B.S. Bajwa. Then another colleague, or you can say we call ourselves Guru Bhai, Dr. Walia, who is in Taiwan nowadays, Professor Sannapa, Professor Gauri Shetty, and my old-time friend, Professor Tibur Kovacs, all delegates sitting over here. In fact, I'm having some shortage of, I don't know why, because when you say that if all is well, if end is well, and it is that kind of a situation. And first of all, I will say that I'm really very happy. I think we all are very happy that Professor Semal is here with us. And yesterday, Professor Kuldeep Singh came to me that why not to invite our mentor, our guide, and our senior. I would say that he is the founder member of the Global University, Professor B.S. Semal. He retired 20 years back and is still maintaining very good health. So it's very nice to see you here. So regarding this event, as I told you, I am really very happy that it has been organized very successfully, and the credit goes completely to the team. And I would like to share with Professor Semali that at present we have 11 students. I was just counting on my finger. At present we have 11 students present here who did PhD from Garhwal University, Physics Department, and they are a part of the organizing committee. So this is, and of course, if I say the 12th member is Professor T.K. Aswal, who is the alumni of our university, and I'm also very thankful to him for accepting our invitation, because I wrote him once that I want to invite you for the inaugural session as a keynote speaker, and he immediately accepted. So it's always very easy for that, because we interacted many times, but he is always helpful for the university. So I'm also very thankful to you for this accepting our invitation. Regarding conference, of course, I will take first the point of Professor Sannapa that we should expand the scope of the conference. You might have seen that we have already extended the scope of the conference. It was not only the radiation measurement, but today we had one complete session for the ion beam interaction, that is the accelerator science, accelerator physics, and all applications of the accelerator physics, either in terms of the nuclear physics or you see about the material science and biological sciences also. So we have already included, and it's a part of our theme of the conference in the brochure itself. So we have already extended our scope, and we are in future, of course, we will
go for that, but we should be careful, we should not forget about the main aim of this society. That when we formed it for the radiation protection or radiation awareness also. So that of course we are extending, and I had an idea from Dr. Walia also in the morning that why not to expand it at the international level, because when we organized it, international conference, so we will go for that, and of course we need your help also. I mean, not only your help, but all of you. And I was present almost in every session in this conference, and I was just looking, around that what is happening, and I can say that it is one of the best conference, because, and most important, you can see that this is the last session, validity session, and generally everybody wants to wind up. Yes. Because there is no audience. But you can see we have full audience in this seminar, and I think if I can count, we have more than 50 people here. And if we have 50% people are still here, so that is a great success of the conference. And the credit goes to the organizing committee. Of course, I am a part, but I am just from outside. Mainly is Professor Kuldeep Singh and Dr. Ashish Saturi. And of course, they have a great potential to organize the events. Professor Kuldeep Singh, he organized, of course, with me many conferences in New Delhi when he was in New Delhi. You might be knowing. And Dr. Ashish Saturi, I heard many times he used to organize the various events in his college. And this, I think, this is the first international event, and he organized it very successfully. So my best wishes for you. I think you have the potential for that. So, and then now both are in Dehradun, so you can organize the event in future jointly. Regarding the other event in the RADNET conference or in this conference, the important was that we organized two special sessions on the establishing a network between Asian and African countries. And I also told you in the beginning of the inaugural session that it is a sort of the collaboration, because you know that it's not possible that each and everyone goes and make the measurement at different places, and then how to make the comparison if you don't have the measurement. Otherwise, you can say that this is my result and this is the final. Like you can say the instrumentation. Until and unless we have the intercalibration facilities or intercomparison facility, you cannot say that your instrument is okay or your instrument is fine. That means you always need to standardize the instrument before taking the measurements. But the same thing, I will say that is for the measurement, or that is for the experimental or theoretical purpose, so that you should have the data from the different places, and for that you need different persons from the different places, and then have a collaboration. So that particular session, you might have seen that is the collaboration between Japan, Thailand, India, then some Middle East countries, and Egypt. These are the countries, and this is wide open. That's wide open. You might have seen the lecture of Professor Inove, and this is wide open. And anybody who is interested to join this, anybody who is interested to put the suggestions before us, you are most welcome. So that is one important aspect I believe that we have presented before you in this conference. And another important is, again in the same session, or again in the same line, that we are going to launch a new association, that is the Asia Oceanica Radon Association. And so that will be launched in the month of September in the University of Nagasaki. And you all are again welcome to join it, because you have seen the presentation by Dr. Omori, that he has given the email address of Professor Tokonami and others. So you can write to them, and you are most welcome to join it. So these are two important events which have taken part in this conference. And regarding the quality of paper, I think all papers are of very high quality. I don't mind if there is a negative result. Result is result. Either positive or negative. The only thing is you have to realize. Either if you have the negative result, why it has come. Maybe you are missing something. Or it may be true that it is a negative, it is not negative, but it is a positive, but we are missing that. So that way, if there are negative results, it's not a problem. But result is result, and the only thing is how to interpret it and how to present it. And the presenter, especially the young researchers, few of the young researchers, they made very nice presentations. Unfortunately, I could not go to the poster presentation because of my engagement here. I was just looking after all these activities, that how they are doing and what is the quality of paper being presented here. Unfortunately, I could not go here. But in oral presentation, I have seen that we have covered almost all aspects, either environmental related or earthquake or even the mineralization. We have covered entire activities in this conference. And it's not only, you can see that awareness and detection, it's radiation. So radiation may be in any form. So it's not like that we are concentrated only on radon or thoron, or maybe you have the paper on strontium also, which is the fallout radiation. You have concentration on the natural radiation, and we have concentration almost all aspects of the radiation. So that way, I believe that we have covered almost all aspects of the radiation in this conference. And in true sense, because we had, if I remember exactly, about 15 participants from abroad, and more than 100 participants from different parts of the country. So it was a very nice gathering from all over the country, or I will say that from all over the globe. So I congratulate once again to the organizer of this conference for making it a successful conference. And of course, the organizers have something for you, from the audience. So you all will have some important surprise, like in the form of the award or in the form of some other memento. So with these points, I think I should conclude. Thank you very much.
Thank you, sir. Ladies and gentlemen, I feel highly privileged to invite our esteemed guest of honor, Professor B.S. Senwal, former head, Department of Physics, H.N.B. Garhwal University, to address the gathering. Sir, please.
Honorable members sitting on the dais, and all my friends, as a participant or as a listener, I think I am grateful to the organizers to invite me to this August gathering. I am an old man, and I am happy to see my friends here, my students here. They are flexing very nicely. So I can't say anything more. I bless them all to prosper more and more. Thank you.
Thank you, sir. Ladies and gentlemen, distinguished guests and participants, it gives me great pleasure to invite our esteemed chief guest to address this valedictory function. Dr. D.K. Aswal's expertise and knowledge have been a source of inspiration for many, and we are honored to have him again with us today. His presence and words of wisdom will undoubtedly make this ceremony a memorable one for all of us. Please welcome Dr. Aswal with a round of applause.
So, namaskar to all of you. And when personality like Professor Senwal is there, I don't think we have to say much. When we were a student, MSc student, and he used to teach the mathematical physics, and the kind of passion and energy he used to have, and it was what I call is that a learning path. And we are very happy to see your good health, and wish you to continue your excellent health for at least a century. So coming back to this symposium, good thing first, the thing is that so much of audience, close to 100 at the end of the symposium is remarkable. It means the community is keen to learn, sit together, understand. The topic was well taken, as I already elaborated on my inaugural address. Radiation is something like which cannot be seen, cannot be felt, cannot be touched upon. So all our five senses cannot recognize the radiation. Only thing we can do is the measurement. And fortunately, we have got a GM counter and cesium iodide, sodium iodide crystal, where we can not only measure them up to a single photon, but also we can distinguish what are the gamma photons we are getting. So, when you have an instrument in your hand, you will always detect some radiation in it, wherever you are. And therefore, the forces in the world, because of their own motivation, they termed it as a ghost. And many times I give analogy in my childhood, when my mother and my grandmother used to say that in the night, don't go outside, there is a ghost. So in fact, I used to ask my grandmother, have you seen the ghost? No, I have seen, but I will not tell you what. So how does it look like? So only when I was in the 10th standard, I wanted to prove that there's no ghost. So in our Uttarakhand, we have got the houses, staircase basis. And in front of our house, little away, there was another house, and there was one house on the top. So my mother once said that I saw that ghost going through that wall. So finally, it turned out to that because there was no light on those days. So it was a Petromax in the top house when they used to bring, and there was a banana leaf which used to shake, and the shake was moving. At the moment she takes away the Petromax inside, the shadow is gone, and the ghost is gone. So this is a real story. And same is with the radiation. Radiation is everywhere, and there is a radiation protection. How you can protect the natural things? And that's why when I showed that arrow spectrum, right from the radio waves to the gamma rays, we should call it a disciplined radiation. You see, when we are sitting comfortably here, it means Mother Nature has given us a disciplined radiation. The food of thought was that what this radiation is going to do with body or is doing with our body. We should not say that let us protect the people from the natural radiation. In Kerala it is under 250 millisievert. So we have got nuclear energy in and around, and we have got a tight restriction. The average radiation field is 2.5 millisievert a year across the country, across the globe. Somewhere it is 50, somewhere 250 places. Now, what the law says is that if you have a nuclear reactor, you should not exceed 1 millisievert. And this I have been arguing with the ICRP, UNSCARE at all the point. And in fact, everybody feels that this is one of the most nonsense thing to happen in the field of radiation. So I'm not saying that what we are doing is not that. We have understood how to use the instrument, how to do research, how to find the radioactivity in the one. What most important thing is that how we should use this radiation for the well-being of the humankind. That should be more. You see, for example, as I said in my introduction, that America has taken these seeds to the Indian International Space Shuttle. As you know that we have got the International Space Shuttle, which is lying on the low orbit, Earth orbit, roughly 400 kilometers from here, and they are seeing that what kind of changes these seeds are taking place genetically. So the focus should be more on how we can control use of these radiations. So unfortunately, the low radiation doses which are available in the nature, you can't really do anything with them. Only you have to create the artificial radiation doses and use them, like the FAO, Food and Agriculture Organization, has produced 3,000 odd varieties of seeds. You can grow them in any of the climatic condition. BRC itself has grown 60 varieties of seeds. The nuclear medicines. Now, because of the fear of radiation, what has happened is we don't have much of the nuclear medicine center across the country. As I said that the cancer is because of our metabolism largely, followed by smoking and followed by other things. In India, I don't know whether you know this data or not. In India, 850,000 people die every year because of the cancer. And one of the reasons of dying so many people are that we don't have the cancer hospitals across the country. So far, we have got only 240 nuclear medicine centers across the country, and there are very few cancer hospitals who deal with the radiation therapy. One of the reasons this radiation therapy was not used in many states is that most of the government didn't like radiation source to be put up in their state, thinking that this will cause the radiation. Okay. So we should be a little careful that the school of thought that has been given over a period of time, that was not a correct school of thought. So that was almost like the ghost of my mother or grandmother. The reality is altogether different. For example, radon has also been discussed since 1950s, 60s, that it will be detecting the earthquakes, a precursor to earthquakes. A huge amount of work has been done. Even BRC has got roughly now 80 radiation monitoring, radon monitoring centers across the country. Do we really believe that with this kind of signal we will be able to predict the earthquakes? It becomes difficult. I myself personally analyze those data. Once the earthquake has taken place, then of course we can correlate. Because of this is happening. But the prediction is difficult. Almost impossible. So why should we spend our energy, manpower, time? We have got more fundamental things to do. Like Marie Curie, when she started her thing that what is that is causing the radioactivity, and she discovered so many polonium, radium, and other. Are we going for that? So the focus of science should be entirely different. Measuring that is not of use nowadays, because there are many other methods by which the mapping of radioactivity in the environment can be done. Again, the trace element like uranium or arsenic or heavy metals, they really do not cause much of the problems, because as I said that we always have a biphasic effect. Biphasic effect means at low doses the body does the adoption, and therefore by and large it is beneficial. Almost it depends on where the dose is. But of course beyond the dose it is a very, it can be dangerous. So find those threshold. So one of the research one should do is that identifying the threshold. The linear no threshold model, which says that no radiation is good for human being, is absolutely wrong, and therefore more and more studies should be conducted to find out the threshold value. Now, how to find out that threshold value? As we know, and I may say that gamma photon is a quantum mechanical particle. The biological process that happens in the systems are again quantum mechanical. The interaction between the quantum mechanical and quantum mechanical is not understood at all. So can we take up these kind of issues? And that will also tell what is the origin of life. The origin of life, in my opinion, and which Schrodinger and many others studied during early 40s, 50s of the previous century, that probably radiation is the root cause of evolution of life. And in fact, there are many experiments done where the radiation level is dropped down below the ground level in Canada, in UK, and they try to grow the biological samples there. And what they find that if radiation is too low, the cells do not grow. So these kind of experiments should be taken up. So we should mature our experiments we should look into the what kind of knowledge, new knowledge we are looking for it. And for that, I would request all the NSS, please spend at least 1 year reading all the literature in your field, and possible if you can write a review article on that. Once you can write a review article in your domain also and publish that in as high impact journal as possible. And when I ask my students, and can you believe that there are students, those who have published their first paper as a review article in an impact factor of 40. It means when you publish your paper in impact factor of 40, almost you are the star in that field in the international domain. So that is what we should be doing. And writing a review article in a journal of 40 impact factor, it requires a huge courage. So it requires your thought process evoking that what is right, what is wrong, what is right, what is wrong, what is your interpretation. Because all the results that you see, once I was talking to the editor of American Chemical Society, I invited them in. Why do you publish so many papers? If you see the number of journals and articles published in the world are several times higher than the newspaper published in the world. And therefore, these research papers, they are as good as newspaper. You read them and then they say you don't care about that. So our science should make a difference. It should make an impact. That this is a paper we should be cited. This is a paper which is unique. So unless we come to that level where the science is revered by the entire international community, I don't think as a scientific community we should be satisfied with that. So we should take the resolution, and that amounts that we should read a lot, we should discuss more, and these kind of conferences, they provide that kind of environment. So we have to always go one step ahead in terms of the critical thinking, in terms of the critical analysis, and as I said, if we can publish the papers. But one of the things which I feel is that, you see, in our community, the journal impact is 2.5. No, it's not like that. This Nature, the Science, the big journals, they publish each and everything. And it's not that in India people do not publish nowadays. From India, people are publishing in the very high impact journals. So the net message which I would say that, as I said, that radiation protection word is not appropriate, which I have also said in the recently conducted international conference at Mumbai, where we invited the ISAP and UNSCARE, WHO, IAEA. Let us stop fearing the people about the radiation. So that is number one. The moment this happens, the first thing will happen that we can open many cancer hospitals with the ionizing radiation capability of treatment across the country, and we can save so many lives. In my estimate, we should have at least 1,000 hospitals in this country to treat the patients with the cancer. You see, I see them coming to the Bombay, the Tata Memorial Hospital, at the last stage. And then the research should be that because radiation is very high energy, when cancer cells are damaged, as a consequence, the neighboring cells are also damaged because there is a very high energy. Kilo-gray kind of dose is given, not milli-gray dose. So to avoid that, then there should be mediation. So the field is very fantastic. The nuclear agriculture, the nuclear medicine, it's enormous choice like that. So I hope I have conveyed my one. Definitely never be fear of radiation, and don't make people fear of radiation. Radiation protection at 100 millisievert is motivated by the international community for the dust region known to them. And therefore, we should work, particularly quantum biology, if you can try out interaction with this, that will be great. One to you and to the humankind. Thank you very much.
Thank you, sir. Now the most awaited moment has arrived. We are going to announce the winners of the poster and oral presentations. give away the certificates, I would request Professor B.S. Bajwa, Professor J. Sanappa, and Professor B.M. Chaube to give away the certificates to the winners. Please come forward, sir. In the poster competition, the winner is Miss Pooja. Please give her a big round of applause. Mr. P.M. Thackeray. Please give him a big round of applause. I request Professor Walia to please join to give away the prize. Mr. Tanaji S. Godke. Next, I would like to announce the winners of the oral presentations. Mr. Sanjeev S. Kanthura. I request Professor Sembal to please give away the certificate. I request Dr. Shelja Pant to please come forward to give the certificates. Dr. Seheli Chaudhary. Please give her a big round of applause. Thank you, ma'am. I request Professor M.P. Nagwal to please come forward to give away the certificate. Our next winner is Mr. Thenarasan Natrajan. Please give him a big round of applause. Thank you, sir. I request Professor Ramola sir to please come forward to give away the certificate. Our next winner is Mr. Satbir Singh. There was a tie, so there are 4 winners. Please give him a big round of applause. Thank you, sir. We are pleased to announce that the National Road-on Network Society, RADNET, is felicitating some of the esteemed researchers by the Radiant Eminent Research Award in recognition of their outstanding contribution. For this, I would like to call Professor R.C. Ramola, President of the RADNET Society, to please come forward and to give the RADNET Eminent Research Award 2023. Professor B.S. Sembal. See the same one. I request Vice President also of the RADNET Society, Professor B.S. Bajwa, and the Treasurer of the Society, Professor Kuldeep Singh, to join Professor R.C. Ramola in giving away the award. The first one, RADNET Eminent Research Award, goes to Professor B.S. Singhwal.
This is RADNET Eminent Researcher Award in recognition of significant contribution in the field of physical sciences to our Honorable Professor B.S.
Please give him a big round of applause. The next recipient of the RADNET Eminent Researcher Award 2023 is Dr. V.K. Aswar.
It's an honor in recognition of the significant contribution in the field of environment radiation safety and awareness. It's an honor to get this award. RADNET Eminent Research Award 2023 to our great scientist, Dr. Dinesh Kumar Aswar.
The next recipient of RADNET Eminent Researcher Award 2023 is Dr. S.K. Sahu. Please welcome him to the stage.
On Dr. Sarath Kumar Sahu, UST Japan, in recognition of significant contribution in the field of environment, radioactivity measurements.
Last but not the least, the RADNET Eminent Researcher Award 2023 goes to Dr. Tibor Koikas.
Dr. Tibor Koikas, University of London, Hungary, in recognition of significant contribution in the field of analyzing radiation and health threats.
Please give him a big round of applause. The RADNET Society is also felicitating Dr. Shelja Pant and her team with a special appreciation letter for their indefatigable contribution in turning this dream into reality.
To the Principal, Dr. PG Institute of Biomedical and Natural Sciences, Delhi. Dear ma'am, please accept our sincere thanks and appreciation for the excellent support provided by you and your staff in organizing the International Conference on Radiation Awareness and Detection in Natural Environment from 2nd to 4th March 2023 at the Dr. PG Institute of Biomedical and Natural Sciences, Delhi, Uttarakhand, India. We have received some very good responses from attendees. We are impressed by the facilities provided by your institute for conducting this event. Your academic, technical, and administrative staff was very skillful in handling the academic conclave and its attendees. The efforts to your team contributed appreciably to the success of the event. The effectiveness of the interaction between the speaker and attendees was enhanced by the timely support given by your staff during the event. We believe this event was one of the most productive ones we had in the past. Thank you once again for the outstanding support and professionally song. Looking forward to working with you.
Please give a So this is a teamwork. It is not joy that makes us grateful. It is gratitude that makes us joyful. Now is the time to show and express our gratitude to all the esteemed guests who have graced the occasion. I request Professor R.C. Ramola to present a memento to Dr. D.K. Aswal as a token of our love and appreciation. So please. Please, big round of applause. I now request Dr. Shailja Pant to acknowledge the benign presence of Professor B.S. Sehwal by presenting a memento to him. Now I request Professor Kuldeep Singh to present a memento to Professor R.C. Ramola as a symbol of our appreciation. I request Dr. Ashish Raduri to present a memento to Professor M.P. Nagwal as a token of our gratitude. I humbly request Dr. Shruti Sharma to present a memento to Professor V.M. Chaube as a symbol of our appreciation. Thank you, everyone. As the organizing secretary, Dr. Ashish Ratuli has been the driving force behind this conference, and his tireless efforts have been instrumental in making it a success. It gives me immense pleasure to invite Dr. Ratuli to present a vote of thanks. So please.
Thank you, ma'am. Actually, my work has been made easily by the Professor Kuldeep. He already made a vote of thanks, so no words for vote of thanks with me. But I want to say one thing. A famous poem by the Needles in Hindi, I will translate it, and the same analogy will to extend in English. विश्व चाहे या न चाहे, विश्व चाहे या न चाहे, कोई माने या न माने, अब आ गए हैं तो गीत गाकर ही उठेंगे. Definitely, it simply means arise, awake, and not stop till we achieve the goal. Thank you once again, and I would like to thank all dignitaries on dais and all the participants across the globe which came here and presented their work. And simultaneously, I would like to extend my apology if in any part, if any kind of a mismanagement you have shown, definitely will improve and your suggestion will be incorporated in near future. And once again, I would like to thank all organizing committees members, which tirelessly they have been worked since couple of days. So Before signing off, one message to all that roots are lovely, dark and deep, but I have not, but I have promised to give miles to go before I speak. Once again, a big thanks to all. Thank you guys.
I request all of you to rise back for the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगल गायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 जय
I would like to thank all the participants, speakers, sponsors, and the organizing committee in making this conference a success. I hope that this event has been a meaningful and memorable experience for all of you. Thank you and have a safe journey back home. Please, all of you assemble here for the group photograph. Only the organizing committee, please.